Awesome, students. Hopefully your day is going well. Sorry for recording this so late. Let's continue with problem D or part D. Let me go look at my steps. Okay. So part D, we are still analyzing the polynomial, and I'm sorry, not polynomial, rational function using the 7 steps. Okay, so we are going to do step number 1 right here. Step 1 is sets, factor, and find the domain. So key points or keywords are factor and domain. Okay. So on the numerator, because, how can you see that, by the way? Let's make it darker. It looks really bright, and then every time okay. Let's make it larger. Is that slightly better? Okay. So when I factor out the numerator, r of x equals the definite 2 square, so this is x plus 3 times x minus 3. On the bottom, the two numbers that are a factor of 18 that will add, give me 9, is 3 and 6, okay? So x plus 3 times x plus 6. Let's test it out to see if it works. X times x is x squared. X times 6 is 6x plus 3x in the middle. That's going to give me 9x. 3 times 6 is 18. Therefore, it works. And then it says find the domain. Then the domain is going to be all real numbers, not including -3 and -6. Okay. Keep in mind, step number 1 did not say reduce. So do not reduce. Don't jump to step 2. Okay? Don't step over my boundary. You got it? Okay. That's what step say. That's what step number 2 would say to step number 1. Okay, step number 2 is that write r in lowest terms. This is when you can. Okay, this is when you can reduce. So don't reduce when it didn't say so. Because when you are reducing, you can cancel out the x plus 3 and an x plus 3 on both top and bottom. You are now going to end up with an x minus 3 over an x plus 6. Okay, that's all step number 2 is doing. Then if I were you and if you are listening, write yourself a note. Okay? From now on, from steps number 3, from steps number 3 to step 7. Okay, so steps 3 to 7. Use the equation from step 2. Okay, give yourself a note. That way, you're not going to make any silly mistakes later. And no, I'm not going to spell it out for you. You're going to have to spell that out if you're listening. Step 3 says locate the intercepts of the graph. So x-intercept, box that up. That's where I'm going to put my final answer. Okay. Y-intercept, box that up. That's where I'm going to put my answer. Then it is asking you to find the x-intercept. That means I'm going to take my numerator, set it equal to 0. So x-intercept is at positive 3. So 3 comma 0. Y-intercept is when x are both zeros here. So y equals to -3 over 6. Oops, you can't see that. Reduce that down to, this is a -3. It's going to be -1/2. So that's why I'm going to put my y-intercept. 0 comma -1/2. Okay. Okay. So step 1, step 2, step 3. Step number 4, where would I put this? Can we put this, how about over here, okay? Step number 4. Step number 4 says locate the vertical asymptotes. Okay. Now, for this particular example, because we did reduce something, I'm also going to add, and this is the way that your test will be. Locate VA and holes, if any. Okay, so let me spell this out. And again, this is the way that your test will be worded because now we actually have a hole. Up to this point, we didn't have any, so I didn't have to fix this, but this is what's going to be. Locate VA and holes if any. Okay. We do have a VA. We have one VA, which is the denominator. Keep in mind, okay, this says that you should be using the reduced form from steps 3 to 7. So that's why I'm only focusing on this. Your VA, okay, it's x equals to -6. Then you do have a whole, and I'm going to, whole is created when you reduce, okay? Because we did get rid of this thing right here, okay? The x plus 3. So we're going to take x plus 3 and we are going to set it equals to 0 to see where the whole is. So subtract 3 from both sides. X equals -3. So we're going to say, hey, whole is at, oops, my light turned itself off. I have a coordinate -3. I also would need to find the y coordinate by putting -3 back into my step 2 function. So we're going to plug x back into r of x. Okay, remember, we only use the reduced form. So r of x equals -3, which is your x, minus what it had before, which is -3, over x is -3 plus 6. This is going to give me a -6 on the numerator divided by a +3, reduces down to a -3. So the whole is going to be at a -3 comma -2. And yes, you have to find where it is located. So that's our step 4. We added a whole now in our direction. Step number 5. Okay. Step number 5 says for us to do what? I forgot. Okay. Step number 5 said OA or HA. Okay. And then it said intersect or not intersect. Okay. So intersect, question mark. So first we have to decide from our reduced function. Is the degree on the top bigger than the degree in the bottom? Okay. It is not bigger, so we will have an HA. And because it's an HA, we are going to find the end behavior on the numerator, which happens to be x, divided by the end behavior on the denominator, which is x. Reduce that down to a 1. So HA, y equals 1. Then we have to see if our rational function will intersect at 1. I'm sorry, intersect our HA or not. So take your y value, which is 1, set it equals to x minus 3 all over x plus 6. Okay. We are going to cross multiply butterfly. I'm just looking for a color pen. Interesting. I don't have any. I don't know where all of my pens, they disappear somewhere. All right, here we go. 1 times x plus 6 is going to be x plus 6 equals 1 times x minus 3 is going to be minus 3. Okay, x minus 3. We have x's on both sides. They can both cancel each other out. So 6 equals -3. This is never true. So no. Okay, so we're going to say r of x will not intersect our horizontal asymptote. All right, that is step number 6. So let's move on to step, no, I'm sorry, that was step 5. Let's move on to step 6. Step 6. Step 6 says create a number line. So I'm just going to write number line. Okay, and remember, on this number line, we are going to put in your x-axis. So let's find those. Where were those values at? X-axis, where is it at? Right there. Okay, I have 1. So let's put in 1 at 3. Then we are going to put in VA. We have a VA negative 6. Oh, I should have moved this over. Let's move this over. So negative 6 and 3, just to make it kind of even and look pretty. Then let's test it out. We only have one VA, one x-intercept. We're good. Then let's pick negative 100. Negative 100 minus 3 is negative. Divided by negative 100 plus 6, negative. Negative divided by negative is positive. So this is now positive. Pick something in the middle. F of 0 equals 0, 0, negative 3 over 6 is a negative number. So negative. So negative. F of 100. 100 plus 3, that's going to be positive. 100 plus 6, that's positive. A positive divided by positive is then a positive. Okay. Then step 7. Step 7 and step 6, they go hand in hand. Okay, graph. Hand in hand because we're going to graph it by hand. All right. I'm going to look for a ruler. Don't have one. So a deck of cards it goes. Okay. Arrows, arrows. Let's move up. Arrows, arrows. Okay. Step 1, step 2. Can't use them for graphing, but I can definitely use step 3. X-intercepts positive 3. So 3 comma 0. We can use y-intercept. Here's 1, here's 2. Okay. 0, negative half. So here's 0, 0, negative 1 half. Step 4, VA at negative 6. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. X equals negative 6. What else? I have a hole at negative 3 comma negative 2. So 1, 2, 3, a hole somewhere here. Label it. Hole. Negative 3, negative 2. Look at that. So that's your step 4. Step 5, we have an edge A at y equals 1. And step 6 was number line. All right, so look, we have enough information to help us out, okay? Which I'm going to use a awesome color pen. We have an asymptote at negative 6, so this is what negative 6 is. It said everything on the left-hand side of negative 6 should be positive. So we are going to go above it. And yes, you can, okay, I'm out of space. So I'm going to go as far up as I can. So that's the left-hand side. Then it said in between negative 6 and negative 3 must be negative. I'm sorry, negative 6 and positive 3 must be negative. So here's negative 6. Here's positive 3. Do you see that the dots are already there for us? Okay, so all we have to do is connect it. Yes, the hole is on the curve, not up in the air somewhere. Okay, the hole really represents that it doesn't even exist. So if you put it like here, it doesn't make any sense. Okay, you can't have a hole here because a hole meaning that is not there to begin with. So why would a hole be in the middle of holiness? So make sure the hole is on the curve. Okay. Then on the right hand side of 3, it says that it's going to be positive. But remember, R of X would not intersect HA at all. So please don't touch my asymptote. So go get very, very close to your asymptote without touching your asymptote. You got it? Okay. Kiss your asymptote without really touching it. All right. 1 VA, 2 curves. Isn't that gorgeous? All right, guys. That is one of our problems today. Now we are going to go on to the next one. If I did say something too fast or you didn't catch what I said, please rewind, listen to it again. Okay, example, dosed. Example 2. Find a rational function that might have the given graph. Okay. Now this is going to be kind of difficult, so please pay attention. Okay. The first thing we're going to find is all the stuff that we had before. X-intercepts, okay? VA, Y-intercept, all of the stuff that we would normally do if we were to analyze them. So X-intercept, we have, 1 and -2. You can see that right there? And that is touching the x-axis, okay? So it should be an even multiplicity, okay? Then we have another one at 5 that is crossing, so crosses, so you can have an odd multiplicity. Okay, I'm going to move down the VA a little bit. VA, looks like we have 2 of them. X equals, oh look, they gave it to us, -5. And X equals to +2. We do have a horizontal asymptote at, looks like, let's count. Oh, they gave it to us, Y equals 2. We have a y-intercept, do we not? Okay. Y-intercept at -1, -2. Looks like -2, right? So 0, -2. Anything else that you can spot out? Okay. Now that we kind of gather up all of the information by just looking at it, let's write a rational function, r of x. Alright, so now I'm going to ask you this question. If you have x-intercepts, where should we be using it? Should we use it on the numerator or on the denominator? We should be using it on the numerator, because before, when we were analyzing to find the x-intercept, we used the numerator to solve. Now we're just going to go backwards. We have the x-intercepts. Looks like we have 2. We just have to put it back in the numerator. So this goes x minus. This is a -2, and this is a -5. Okay. Well, when x is at a -2, the curve touches the x-axis, so we need to give it an even multiplicity. So you can do 2, you can do 4, you can do 6, but usually I would like for you to use the smallest number you can use. Okay? And when x equals to 5, it crosses. That means an odd multiplicity. You can do 1, 3, 5, but again, I would like for you to use a small one, which is a multiplicity of 1. You don't have to write 1, but you can. So check. And if I'm taking notes for the very first time, I would write myself a note saying that where this goes on the top, on the bottom. So when you are studying or when you're doing your homework, hey, you know what? Let's plug it there. Let's put it here. Okay. Step number 2. We have a VA. Where do you think this is going to be at? On the top or on the bottom? On the bottom, because we would need to use a VA to solve for x. So we have 2 VAs, so that's going to give me 2 asymptotes here. So x minus a -5 and x minus a 2. And believe it or not, VA also has a multiplicity. So now this is where I want to focus. Okay. Now let's look at, do I have any other problems? Okay. To compare. Looks like I don't have anything. So we're going to talk about the multiplicity of VAs. Our first VA is when x is -5. Notice how the left curve goes straight up and the right curve, when they're approaching this VA, is down. Notice how the two curves approaching the VA is going opposite directions. Okay, so one more time. The two curves, right curve approaching this VA and the left curve approaching the same VA is going the opposite direction. That is an odd multiplicity. Okay, so for VA, opposite directions. Odd multiplicity. Okay. Then, so that means this right here, I can give it a 1, a 3, a 5, whatever, but I'm going to give it a 1, which I'm not going to write. Then let's look at the other VA, x equals 2. Okay. Left curve approaching this VA, and the right curve, they're both going the same direction. Okay, so opposite directions. Same direction. Guess what kind of multiplicity that is? Even multiplicity. Okay. This is so important. Make sure you know that. So that means over here, I should give it a 2. Okay. I'm just going to polish this up a little bit. I'm going to go in and make all the positives, the two negatives, positive. So this is x plus 2 squared times x minus 5 over x plus 5 squared times x minus 2. Okay. I'm sorry, no, this doesn't have a square. I want to make sure I'm doing this. This one has a square. Because this is where they both were going the same direction. Okay. So now that I polish it up a little bit, we also need to check if we have a y-intercept at 2 and an h at 2 and a y-intercept at 0, negative 2. Okay. Y-intercept is when x is 0. So when x is 0, okay, we have 2 squared, which is 4. 4 times negative 5. Right now that's negative 20. When x is 0, this is 5. 5 times 4, it's also, so that's 20. So currently, we have a y-intercept at negative 1, which that's not what we want. We want to have a y-intercept at negative 2. And in addition, we have not done anything to address this, okay? And so we need to address both of these, the last two pieces. Well, I want a y-intercept at 2. Currently, would you agree that this both has a degree of 3? Degree of 3 and degree of 3. So if I ask you to find the horizontal asymptote, it would be a y equals to 1. The only way to make it a horizontal asymptote of 2 is to give the numerator, a 2. So that way your end behavior, so end behavior on the top divided by the end behavior on the bottom. So the end behavior, this is an x squared, this is x, so that's x to the third times 2, that's 2x to the third. On the bottom, this is x squared, so when I add them together, 1 power 2, that's x to the third. Okay. So if you look at it, my end behavior on the top is 2x to the third, my end behavior on the bottom is x to the third. Now, I do have an h8 y equals 2. So check that, we use that. Now let's check this equation again to see if our y-intercept is where it is supposed to be. So when x is 0, remember we're checking for y-intercept. When x is 0, this is 0, so 2 squared is 4. 4 times 2, that's 8. 8 times negative 5 is currently a negative 40. Okay. Divided by, when x is 0, again we're checking for y-intercept. So 5, and then this is negative 2 squared, that's a positive 4. 5 times positive 4, that's going to be positive 20. So that's going to be a negative 2. So is our y-intercept at negative 2 now? Okay, this is our check. Yes, it is. So therefore, this is our polynomial. Okay. With that said, like I've mentioned before, that was a really difficult concept to understand. So make sure you guys watch it again if it didn't click the first time around. This is the end of our video notes. Have a wonderful day. Oh, how about a joke? Why did the bird get in trouble in Mrs. Tran-Bloom's class? Because he was caught tweeting on a test. Tweet, tweet. You know, a bird chirping, tweeting. But tweeting nowadays also mean a whole different thing. So don't use your cell phone. All right. Have a wonderful day. I will see you guys next time.